With applications such as ChatGPT making the news almost every day, artificial intelligence has been the most talked about technology of the past year. Yet few people know that the most advanced AI technology depends on a breakthrough made by a team of Chinese computer scientists. He Kaiming, Jian Sun, Shaoqing, and Xiangyu developed a method called deep residual learning to solve a fundamental problem limiting the development of deep neural networks. Neural networks mimic the human brain with data processing nodes arranged in layers like neurons. They achieve their output by being trained, just like humans, by the input of huge numbers of examples.
The fundamental concept of neural networks is to combine many simple functions to represent highly complex transformations. We may think of them as Lego blocks. We can use many simple Lego blocks to build complex shapes.
Every layer that is added to a neural network increases the computing power that is needed to run it. Initially, this limited the technology's development.
In 2012, researcher Alex Krzyzewski and his team designed an 8-layer neural network called AlexNet at the University of Toronto. It outperformed coded programs by a very wide margin to win the ImageNet Challenge, an annual industry standard picture recognition competition. Enabled by faster computers, AlexNet showed that many layered deep neural networks were the way forward in AI. In adding more layers, however, scientists soon ran into a problem.
Ideally, if we add more building blocks to make the neural network deeper, we should be able to have a more capable model. But in practice, after about 20 layers, a deeper network becomes worse very quickly, and we call this degradation problem.
The Chinese team solved the degradation problem of deep neural networks by limiting the distortion that can occur as data is passed between layers.
The idea of residual learning is to let layers represent the changes with respect to their inputs, rather than directly building the output. Such a change is called a residue. Our intuition is to help the network represent identify mappings, and adding these identify mappings would let the layers represent the residues with respect to the inputs.
Using their deep residual learning method, the Chinese team developed ResNet, a 152-layer neural network. It won the 2015 ImageNet Challenge and outperformed humans for the first time. Their 2016 paper describing ResNet has been cited in other papers more than 180,000 times. ResNet is now considered one of the big milestones of today's AI revolution, along with AlexNet and others. Deep residual learning underpinned Google's development of transformers, its neural networks for learning human languages. This has become the global standard for natural language processing and enabled the creation of ChatGPT, a neural network of around 400 layers. ResNet applications include AlphaGo Zero, which quickly taught itself to beat the world's best Go players, and AlphaFold, which is revolutionizing medicine with its predictions of protein structures.
Computer vision has made tremendous progress in the last decade, but it is far from being solved. Ultimately, I hope our research will augment human intelligence with more capable artificial intelligence. I envision artificial intelligence will benefit many aspects of human society.
For fundamental contributions to artificial intelligence by introducing deep residual learning, the 2023 Future Science Prize for Mathematics and Computer Science goes to He Kaiming, Jian Sun, Shaoqing, and Xiangyu.